Good morning, everyone. Welcome to the quarterly meeting of the Technical Oversight Committee. We're going to give the attendees a moment to get tuned in, and while we're doing that, we'll start out with some introductions. What I'd like is for the reps to introduce themselves and then introduce also those folks you have who are panelists on the Zoom call today. So I can start. I'm Julie LaRocque at the South Florida Water Management District. In the audience, technical staff I have here, we have Chelsea Q, Stuart Van Horn, Nenita Rikkinen, Jody Hutchins, and as always in the back, Violetta's back there to help us when we need logistic support, so I'm glad you guys are all here. Donato, if you don't mind, introduce yourself and whoever you have online here. And if you didn't do a mic check with us earlier, please say hello when Donato introduces you. Thank you.
Good morning, everyone. Donato Surratt, Everglades National Park. On the line, I see Melody Naja. Can you give us a mic check?
Good morning, everyone. This is Melody.
Thank you.
Hi.
Bill Walker, can you give us a mic check?
Yeah, good morning. This is William Walker.
Thank you, Bill. I think that's all I see. I do see solicitor Judy Coleman. Do you want to give us a mic check?
He's thinking about it. We'll come back around to you, Judith, because I see you may be trying to get logged in.
No, I'm here. This is Judith Coleman for the United States Department of Justice, and my colleague Mark Wiederschein, I think, is in the public Zoom or trying to join.
Thank you.
Thanks. I did see that name earlier, maybe on the attendees. Mark Schaefer, you have your hand up, so why don't you introduce yourself and if you have any technical staff on the line.
Okay, while we wait for Mark Schaefer, Chris Decker, EPA, I see you online. Can you give us a mic check?
Good morning, everybody. It's Chris.
Hi, Chris. Okay, Mark, how about you?
Chris.
Is the audio on? This is Mark Schaefer from the Corps.
We hear you. Thanks.
Yeah, thank you, Mark. I think Johanna introduced herself before we went on air, so she's with you guys, correct?
This is Johanna. I'm with the Corps of Engineers.
Thank you. Folks, if you're a panelist and you're not actually speaking, could you please mute your microphone? Otherwise, I got to get somebody in the back to help me do that. So please make an effort to do that if you don't mind. While we're still introducing reps and technical folks, Rebecca Gibble, if you could please introduce yourself. So glad to have you here.
Thank you very much. Rebecca Gibble with U.S. Fish and Wildlife Service.
No, I don't have audio.
I'm stationed at Loxahatchee National Wildlife Refuge, and this is technically my second meeting, but officially my first because I was not able to make it during the last meeting. And I just want to say hello to everybody. I'm really happy to be here and working with everyone. Thank you.
Thank you. I didn't see necessarily any additional technical staff from the refuge. Oh boy, so Donato is actually capturing people now. Also, Kathleen Burchett is in the audience, so thank you for being here, Kathleen. All right, Ed, how about you?
Good morning. This is Ed Smith with the Florida Department of Environmental Protection. I believe online we have, for technical support, we have Mylene Sotolongo Lopez, Jordan Tidio, I believe our attorney Kenny Heyman is on, and can't see anybody else, so.
Nope.
And Chuck DeMonico, our outside counsel, will be on shortly. He teaches he's teaching a law school class and will be joining us here momentarily.
Thank you for that. Okay. I do have an email from Mark. Hopefully we resolved the issue for him, but we'll check again. Last but not least, Mr. Barquette, our special master, if you could please introduce yourself.
Good morning to everyone. This is John Barquette, Special Master appointed by the court.
So, Mark, I have your email, but I think we heard you. So are you good? Or are you not receiving any audio right now from us? Guys in the back, it looks like I have a TOC rep who's not able to receive audio. If we could see how we can help him fix that, I would appreciate it. Mark,
Julian, I think I have audio now.
Oh, great. So you can hear us. All right, perfect. Thank you.
Yeah.
That's always the adventure. All right, great. So we'll move into a few things. First of all, for everyone, even when we open for public comment, if you're not speaking, please do mute your microphone. I'm on a new laptop. I think I got everything turned off here that's supposed to be. Let's see, reduce the volume on your computer to 0. That's so we don't hear an echo. And again, if possible, and I realize you may have technical difficulties, try to listen to the meeting from only one source. And let's see, we've got that. All right, if you would like to speak during the meeting, so participants are able to actually unmute themselves and speak. If you're a representative, you should do that. So that's you, Mark, because the rest of us are in here. But also, if your representative asks you to speak while we're having discussion, we'll do it that way, and then you could unmute yourself. Let's see, panelists, please raise your hand if you're able. And the way you do that, if you're on the phone or unable to do it using Zoom, you can actually raise your hand by pressing *9. And you can unmute your microphone by pressing *6. So just so you guys are aware of that. All right, we will take comments on agenda items at the end of the meeting unless we decide to vote on something, in which case we would take those comments before we vote. And, you know, for those of you who are attending, you know, the auditorium seems kind of empty, but I see we have like 32 people who have called in as attendees, so really appreciate you being here to listen in. Public comment, if you are providing it in person, we ask you to fill out a public comment card. And we've got the raise hand, we talked about that. Okay, I think, and we don't always respond to public comments during the meeting, guys. Sometimes they're related to things we're talking about, obviously, but you may or may not get a response today. You might get a response on a different day. We will look at some action items for the next meeting at the end of today. And then let's talk about what we have out there for you guys. So first of all, under the read aheads, we have a first quarter of calendar year 25 report presentation, which Chelsea will be giving. We have draft TOC meeting notes, and we did receive a change. I don't think we were able to post that on the web, so we'll read that when we get to the meeting notes. We have an agenda item about water quality conditions in the refuge, and those are also PowerPoint slides. So those are on the TOC website for those of you that are following along. And if you're here in person, Violetta gave you a stack of paper, so you have those. And if we decide to vote on something, we still have the memo from the principals from back in 2016 to kind of help guide our conversation. So those are all on the webpage. Let's see, the agenda should be also there, as well as some instructions, some of which you just heard. And then we have a number of other documents that we typically post. So we have the narrative quarterly report, we have the narrative quality assurance report, and we also have data associated with the quality assurance report posted out there. Those cover the first calendar quarter of the year, which we're talking about today. And then we have the so-called data tables. So there's one for the refuge, and there's also first quarter tracking for Shark River Slough and Taylor Slough and Coastal Basin. So you should be able to access all of those on our webpage. Does anyone have any changes or adjustments for the agenda today? Okay, seeing and hearing none. Let's move on to the notes from the last meeting. So we posted a meeting summary on the website, and we also circulated it to the reps, and sometimes we have a chance to actually adjust what's posted out there, but I wanted to call your attention to the notes. Let me get to So for those of you who are looking at the version that's posted online, we were asked to change one sentence. So you'll find that on page 3, under questions, comments, and discussion. There's a sentence or so there that basically is relatively short. It says results show no impact on compliance when flows are shifted to the S12A and 12B structures, and we did adjust the notes. So when we approve the notes, I'm going to ask that the reps approve the adjustment. So the replacement sentence is, results show no impact on compliance when flows are shifted to the S12A and S12B structures. Oh, that's the old sentence, isn't it? Sorry, guys. The new sentence is, results show no impact on compliance interpretation when S12A and S12B deviation flows were shifted to S12C, S12D, or a combination of the two. So that's the replacement sentence for you guys. Do I have any other comments or requests about the meeting notes, or could we approve them with the replacement sentence?
It was my request to replace the sentence, so I will motion to approve the change.
This is Ed Smith. I'll second the motion.
Okay, anybody opposed to approving the meeting notes with this one replacement sentence? Okay, we're good to go. Thanks, guys. All right, next up is our standard quarterly settlement agreement report. So I would like to welcome Chuck Q to the podium. She's going to give us a rundown on the first quarter of calendar year 25.
Good morning, everyone. I'm Chelsea Q with the South Florida Water Management District. I'm here to present the settlement agreement report for the first quarter of 2025. So we have monthly compliance results for the refuge for the individual month of January, February, and March. For Shark River Slough and Taylor Slough coastal basins, we're in the mid of water year 2025, so we're still presenting the 12-month tracking results. So this summary table provides the compliance results and for all the 3 areas and all the assessment periods. They all looks good except for these 2 periods. The refuge in February 2025 had an excursion here shown in the second row here on this table. And also for Shark River Slough, the 12-month tracking flow with mean TP concentrations shown in this area exceeded its 12-month tracking long-term limit. And this table focuses on the refuge compliance. And here the top section covers the first quarter we are reporting, and the bottom section provides an outlook with preliminary data. So again, you see in February 2025, the refuge geometric mean was 9.4 parts per billion, exceeded long-term level. And all the other months, the next 5 months, all look good. So this slide shows the past 36-month compliance status in the refuge. So toward the right end, in the last 12 months, these 2 red dots shows the 2 excursions happened in October 2024 and February 2025. So 2 excursions in a 12-month period means a potential exceedance. And Jody and Nanette will present a comprehensive analysis of these 2 events following my presentation. So I save the discussion to their presentation. So move on to Shark River Slough. Those results are the 12-month tracking results. They're not the real compliance results yet. So here you can see on the second column, the 12-month tracking flow was decreasing due to very low rainfall in the dry season. And actually at the end of July, the flow was below 1 million acre feet. As a result, the long-term limit increased a little to 8 parts per billion. The flow mean TP concentration also were increasing and also exceeded the tracking long-term limit. So looking at the historical compliance status, so these hashed bars represented the years when we shift the compliance calculation to method 1.5. So for the last 4 years, the most recent 4 years since COP has been implemented, you can see that the long-term limit shown in this solid red line was flat because the limit was fixed at 7.6 parts per billion. And these bars represent the flow mean TP concentrations of the last 4 years exceeded the long-term limit. And this slide shows the daily flow delivered to Shark River Slough over the past 3 years. And here the water year 2025 started in here October 2024. You can see the flow was peaked in November, then decreased quickly in the dry season due to lack of rainfall. And this slide shows the daily flow break down to each structures discharged to West Shark River Slough via S12 A, B, C, D from top to the bottom panels. So here S12A and S12B were closed following their operation schedule. So in October 1st, November 1st, and December 1st. They were closed in the first quarter. Then S12C and D flow also decreased quickly due to lack of rainfall. So this slide shows the daily discharge sent to Northeast Shark River Slough between S33 and S334 in the L29 canal. So in this segment of the canal, you can see the S33 and S33M flow dominates the discharge, about 95% of flow. And this slide shows the same information. And this slide shows the underlying data used to calculate the 12-month tracking flow with mean TP concentration. So we use biweekly flow and TP concentrations. So are these blue bars represent the biweekly flow, and these cyan dots represented the TP concentrations along with this biweekly flow. So within each 12-month period, the 26 pairs of flow and TP were composite together to calculate one 12-month tracking flow with mean data. So here you can see in this quarter, the TP concentration was increasing. And that composited 12-month flow with mean is shown in the blue diamonds on this figure. So for each ending month, so each blue diamond represents the prior 12-month flow weighted mean TP concentration, and the last diamond represented the 12-month ending March, which was 9.2 parts per billion. So this slide shows the WCA3 stage, the Shark River Slough flow. So the stage is shown in the top solid line, flow is shown in these shaded blue area, and the TP concentration is shown in this middle, these yellow dots. So it covers the 3 water years. So water year 2025 data is still provisional. And after this black solid line, these are the data, the look-ahead data after the first quarter, the reporting period. Now it covers all the way to the end of July. So in water year 2025, started from this last box, you can see that the stage S33's headwater is shown in this red solid line. Stage peaked in November. Also the flow, you see these shaded blue area, the flow peak also in November. Then after that, both the stage and the flow decreased quickly due to we're having very dry dry season and a wet season. So here the S33 headwater showing this red line, you can see reached 7 feet, then fluctuate because the rainfall even in the wet season was very low. And also when the stage was this low, you can see the TP concentration fluctuate in a very large range. So when stage was low, now only the TP concentration was high, also it's unstable, swing in a very large range with very small stage changes. So move on to Taylor Slough and coastal basins. The 12-month, these are also 12-month tracking data with provisional, tracking results with the provisional data. So the total flow was also decreasing, remains about 400,000 acre feet. The flow MTP concentration has been consistent low, about half of the limit, fixed at 11 parts per billion. So looking at the historic compliances, you can see that these bars represent the annual flowway mean has been consistently very low than the limit, 11 parts per billion. So Taylor Slough and coastal basins never had a compliance problem because the limit was much higher than Shark River Slough. And this slide displays the daily flow discharged to Taylor Slough and coastal basins. Here, the top yellow shaded area represents S18C, then move down G737, and this bottom shaded area represents flow at S332D. And most of the flow comes from S18C and S332D. That at the end of the first quarter, actually, flow stopped. This slide breaks down the flow to at each structures. Again, you can see the flow stopped in the first quarter because of very low rainfall we encountered in the dry season. And this slide shows the flow in and out of S332D flowway. And so this red line represents the flow passed north by the S332DX1. It's closed. And also S328 was also closed since the last, last July or August. So the main flow here is just the upstream pumping by S332D. And this slide shows the weekly data underlying data used to calculate the 12-month tracking flow with mean. Here, Taylor Slough and coastal basins, we use weekly flow shown in these blue bars and the weekly TP concentration shown in these cyan dots. And that data, 12-month of data, were composite to the 12-month tracking flow weighted mean shown in these blue diamonds. And the last diamond is the end of March 12-month flow weighted mean at 5.4 parts per billion. So that's all I have. Thank you.
Thank you, Chelsea. Does anyone have comments or questions for Chelsea? Okay, I'm not seeing or any hands raised or anything else. So Chelsea, thanks so much. We'll go ahead and introduce our next agenda item. I did once take a university class that was team taught, and so this next presentation will be team presented. Jody Hutchins, Nenna Rikkonen, and Chelsea Q are all participating in the next presentation. And all three folks are from what we now call the Office of Water Quality here at the district. So we're going to talk about the water quality conditions for the Arthur R. Marshall Loxahatchee National Wildlife Refuge, 24 and 25. I do want to mention, and Jody, you could probably confirm for us, but we circulated a draft version of these slides to the reps, and I think based on comments, there may have been a couple of modifications made, but the version that's posted on the webpage right now is the version we're presenting today. So go ahead, Jody.
Hi, good morning, everybody. As Julie mentioned, I'm Jody Hutchins with the South Florida Water Management District, and I'm here with Nenad Arikanen to present the water quality conditions for the excursions observed for the Arthur R. Marshall Loxahatchee National Wildlife Refuge, known as the Refuge, following the provisions set forth in Appendix B of the consent decree. I want to give a special thanks to Chelsea Q and Nenad Arikanen for their assistance in the development of this presentation, and also for the TOC reps for their review and comment on the draft version that was shared. So this slide provides the consent decree compliance determination as specified in Appendix B. The compliance methodology, it's based on a relationship between stage and concentration to calculate a long-term level. The map shows the 14 compliance water quality stations shown in red, and the 3 stage monitoring stations shown by the black triangles used to assess compliance. Compliance is assessed monthly, and an exceedance occurs if the long-term level is not met for 2 or more times in a 12-month consecutive period. And the consent decree also indicates that compliance is expected to provide a marsh concentration of approximately 7 parts per billion. This graphic provides a history of the water quality conditions in the refuge for the long-term level period beginning in 2007. The top portion of the figure provides information related to stage, and the bottom portion provides information related to total phosphorus concentration within the refuge. The blue line shows the mean daily stage for the refuge and how it relates to the refuge's regulation schedule shown by Zone A1 and Zone A2. For the refuge compliance assessment, the stage observed during sampling, which is shown by the crosses, is used to calculate the refuge's long-term level, which is shown by the solid red line. The compliance equation has upper and lower bounds, shown by the dotted lines for both stage and concentration. For stages at or above 17.14 feet, the long-term level is set to the lowest at 7.2 micrograms per liter. And for stages at 15.42 feet, the long-term level is set at the highest of 17.5 micrograms per liter. And if stages are below the 15.42 feet stage, the long-term level is not applicable. The water quality data for the 14 compliance stations are used to calculate a total phosphorus geometric mean, and that is shown by the circles. If the geometric mean is below the long-term level, then there's no excursion, and that is shown by the blue circles. If the geometric mean is above the long-term level, then we have an excursion, and you can see those instances for the long-term level shown by the red circles. You will notice that excursions often coincide with the upper stage range of the compliance equation. So above this dotted 17.14 line. And also, we notice that excursions occur following a rise in stage in the refuge. So I'm highlighting those occurrences. You can also see that the last exceedance that we had in the refuge was about 10 years ago, back in 2015. This figure is the same that was shown on the previous slide, but this zooms in to the previous 12-month tracking period. And you will notice the two excursions, one in October of 2024, shown by this red circle, and then the one in February 2025. There's another red circle. For October, you will notice the rise in stage within the refuge, and we're also at the upper level of the stage range, where the long-term level is set at the lowest at 7.2 micrograms per liter. And for October, because the 14 station geometric mean was at 7.5, which was greater than the long-term level, that indicates an excursion. For February, we were on a receding stage within the refuge. We were at the 3-gauge mean stage at 16.61 feet. That brings us to a long-term level of 9.1 microgram per liter, and the geometric mean concentration was 9.4, so therefore we had another excursion in February, because these two excursions occurred within a 12-month period. This slide provides an outline of the evaluation of this potential exceedance. The consent decree states that an exceedance will constitute a violation of the agreement unless the TOC determines that there is substantial evidence that it is due to error or extraordinary natural phenomena. And this presentation includes information to inform the TOC on the conditions surrounding this potential exceedance. So this slide shows how rainfall within the refuge, shown by the figure at the top, and how the refuge's inflows and outflows, shown by the figure at the bottom, may have played a role in the stage observed within the refuge, shown in the middle portion of the graphic. These dotted vertical lines are the exact compliance sampling days for both the October event and the February 2025 event. Leading up to the October event, you can see there was a combination of rainfall as well as inflows and outflows to and from the refuge. And the combination of both the rainfall and flows entering and leaving the refuge both played a role in the rising stage we saw preceding the October event. Hurricane Milton occurred in October, which also impacted the refuge. However, this event occurred 1 week after the October sampling event. Leading up to the February 2025 event, you can see there was an insignificant amount of rainfall, as well as an insignificant amount of inflows and outflows from the refuge. This figure provides the refuge's monthly rainfall amounts compared to the 30-year mean for the 12-month tracking period. In October, you can see that there was a deficit of about 0.7 inches of rainfall, and in February, there was a deficit of 1.6. Based on these rainfall totals and the review on the previous slide of the refuge inflows and outflows, as well as tropical systems, there does not appear to be evidence of extraordinary natural phenomena surrounding the two excursions observed. This slide provides an evaluation of error and whether it played a role in the October 2024 and February 2025 excursions. Missing data qualified data, and anomalous data were reviewed for both stage and water quality. For stage, there was no evidence of missing data, qualified data, or anomalous data in either October or February 2025. For water quality, there was no evidence of missing data or qualified data in October 2024 and February 2025. Let me just take a moment to explain missing data for water quality. For the refuge, often when the water depth is below 10 centimeters, we are unable to collect a sample. This is not what we consider missing because the attempt was made to go out and collect a sample. However, conditions did not allow for a sample to be collected because of water depth. We don't consider that missing. What we consider missing is if the water depth was sufficient enough to get a sample, however, we were unsuccessful because of other factors. For example, helicopter inaccessibility, weather, or other issues that may have prohibited collection. So we did not have that situation in either October or February 2025. For anomalous data, we did not have any evidence of anything anomalous occurring in October of 2024. However, in February of 2025, there was one sampling event collected at the LOX 8 station with a total phosphorus concentration at 21 parts per billion. Because this sample was very suspicious and was at the high end, what we've seen historically at the stages observed during February, and also because we took a look at the stations surrounding LOX 8, and none of the other stations appeared to be within the range we saw at LOX 8, we launched an investigation right away. For example, we had the LOX 8 sample reanalyzed to make sure that the measured concentration was valid. So everything checked out with the reanalyzation of that sample. And we also took a thorough review of the quality assurance tests because the data was not qualified or flagged. And everything checked out as far as the quality assurance protocol is concerned. So because this value is very suspicious, what we did was we conducted a sensitivity analysis. So for the February event, like I mentioned, we have a level observed at 21 parts per billion. The 3-gauge average stage within the refuge was 16.61. That brought us to the 9.414 station geometric mean, which exceeded the long-term level of 9.1. So what we did is we took a look at what were the concentrations measured at LOX 8 in the month prior to February and in the month following February. And we see that in the month prior, which was January, we had a level measured at 9 parts per billion. And you can see the similarities in stage between January and February. So one would expect that the concentration would not vary that drastically. So by substituting the 9 observed in January for the level that was observed in February, the 21, and the 14-station geometric mean calculation for February, this brought the 14-station geometric mean down to 8.8. So in that case, compliance would have been achieved because we would be below the long-term level. Similarly, for March, the month directly following the February event, the measured total phosphorus was 10 parts per billion. You can see the stage was somewhat lower than what was measured in February. However, the concentration wasn't much different than what we saw in January. However, it was drastically different than what we saw in February. But in any case, we went through the same exercise. We substituted the 10 for the 21 for the February 14 station geomean, and that also brought us to 8.8, which is less than the long-term level of 9.1. The next exercise that we did was we looked at, well, what happens if we just exclude the February LOX 8 data point altogether from the 14 station geomean? Because this is how we handle the situation when we have qualified data. We exclude it completely from the calculation. So we were curious, in the event that there is evidence of anomalous data and this data point is qualified, what would the 14 station geomean have been? It would have been 8.7, which is less than the 9.1 long-term level. So the next several slides, we go through a very thorough evaluation of this February LOX 8 2025 sampling result. And this is just to try to better understand what was going on at LOX 8. Why do we have such a high level? It's very strange. And is there any evidence of it being anomalous? Or is this something that is typical for LOX 8? Those are all of the kinds of questions we were trying to answer with the analyses that we are going to walk you through on the next several slides. So what we first looked at was taking a look at all of the historical data we've measured at LOX 8 for the long-term level period beginning in 2007. So this figure provides the individual sampling results at LOX 8 versus the 3-gauge average stage and the refuge for the long-term level period. The long-term level reference line is also shown in red for the calibration range. So you can see below the 15.42 feet line, the line does not continue because the long-term level is not applicable in that stage range. And then above your 17.14 feet, the long-term level stabilizes and it is constant at 7.2. You will also notice the February 2025 sampling event in red, which is the 21 parts micrograms per liter. You will also notice that historically high total phosphorus concentrations have been observed at LOX 8. For example, we have a 48 microgram per liter data point from April of 2011. We also have a 26 microgram per liter data point that occurred back in May of 2024. And we had several instances of concentrations observed at LOX 8 in the 20 microgram per liter range. However, all of these historical high concentrations at LOX 8, you will notice, were observed at lower stages than what we had in the February 2025 event. And further, these sampling events where we did observe higher TP concentrations, they were very, very dry months. In fact, during these months, compliance sampling can only be achieved at 6 or 7 of the 14 compliance stations. So further reinforcing the very dry conditions, which in those situations, it's not as suspicious to have high concentrations. It is suspicious to have very high concentrations, and that's something that we want to look into. So in February 2025, the stage was at 16.61 feet. And the total phosphorus levels observed at LOX 8 with similar stages. So you can see by the dotted box. So between 16.5 and 16.7, the concentrations historically ranged from 4 to 13 micrograms per liter. And you can see the level in February of 2025 was way outside of that range at 21 micrograms per liter. And just so you're aware, there are about 42 data points within this region shown by the dotted boxed area. One other thing that's worth noting is that the long-term levels for stages at 16 feet and 17 feet, this is also shown. We just want to indicate that a change in the long-term level there's a change in the long-term level by about 5 micrograms per liter with that 1 foot change in stage. And finally, we wanted to look at the distribution of the sampling events at Loch Sades, and that is shown by this box and whisker plot. You will notice the February 2025 21 microgram per liter data point. This is in the outlier region. You would also notice that there are other outliers identified. However, all of these other outliers identified were in the stages that were much lower than what we had in the February 2025 event. And I want to welcome Nenad up just for a second so he can further explain the box and whisker plots, because it's really important for some of the slides to come to fully understand what this is showing us.
Thank you, Jody. My name is Nenad Rikkonen, for those that don't know me. Basically, a box and whisker plot is a statistical way to look at a distribution of data. So the box and whisker plot is made up of a box which contains the 25th and the 75th percentiles as the upper boundaries of the box, with a median shown as a central tendency of the data. And it has whiskers. The whiskers basically account for data that is not deemed an outlier. And in this method, in this particular instance, we're using the Tukey method, which is taking the inner quartile range, which is the difference between the 25th and 75th percentile, multiplying it by 1.5, and then adding that to the 75th percentile to get that upper whisker, and subtracting it from the 25th to get the lower whisker. And things that are outside those whiskers are thought of as outliers. Now, you could also use the extreme method of looking at these whiskers by multiplying, using a 3 multiplier as opposed to the 1.5, and that gives you the extreme outliers. In the case here, if we did that, we would find that there would be 4 data points that would be shown as dots, while the rest of the data points that you see as dots would be part of the whisker, because we would extend the whisker and accept all of those data that are now outliers as part of the data set, and we would just be showing the extreme outliers. So it would be the data point below the red dot, and everything above the red dot would be considered to be an extreme outlier. So that, in essence, is basically the fundamental reason why we use the box and whisker, just to give us an idea of what the distribution of the data historically would be at one station. You will also notice that this particular box and whisker plot, and unfortunately it's just the force of habit whenever I create them, that I also have a notch in it. What the notch represents is the 95% confidence interval around the median. Typically, when you have several of these box and whisker plots with the notches, you could eyeball whether the notches overlap or not. If they don't overlap, you could say that the 2 data sets that you're comparing are not statistically significant, are statistically different, or they're significantly different. And if they overlap, they're not statistically different. Okay.
All right, thank you, Nenad. Okay, so this figure provides a review of how total phosphorus, shown on the left, and specific conductance, shown on the right, for LOX 8 are distributed for the long-term level period. The February 2025 sampling event, shown by the highlighted dot at the top of the graphic, was at the 98th percentile for total phosphorus and the 95th percentile for specific conductance. You will also notice that out of 197 sampling events, the February 2025 event was the third highest ever observed at LOX 8 for TP for the long-term level period. And I'm going to invite Nenad back up to walk us through the next several slides.
Thanks, Jody. Okay. Well, I must say, I almost got myself in trouble today preparing for this presentation. I almost forgot it was my anniversary. But I made it up by actually going to wish my wife a happy anniversary. Okay, so what we have on the screen are the October sampling event data for both TP and specific conductance. I'd like you to focus in on the left side of the screen, which basically gives you the TP concentrations at the compliance stations. We'll get to the conductance in a bit. So the long-term limit in October, as Jody said, was 7.2. The geometric mean ended up being 7.5, and the stage was 17.27. Well, the distribution of TP concentrations during the month of October ranged from 7 parts per billion to 9 parts per billion. Numerically, 8 of the stations had 7 parts per billion, or micrograms per liter, and if you see me switching back and forth, I much prefer talking about micrograms per liter than parts per billion, because micrograms per liters are concentrations, parts per billion are ratios, and they're theoretically incorrect for freshwater samples. But be that as it may, we'll interchange them, okay? So we have approximately 5 stations that had 8 micrograms per liter concentration of TP, and 1 station, that's LOX 5, had a 9 microgram per liter concentration. I'm gonna stick with TP just for a bit. So one of the things we want to take a look at is how does phosphorus behave from the canal into the refuge. So we also have transect stations that are part of our permit compliance that extend from STA 1 East, STA 1 West, and down in the southwest quadrant of the refuge. So I'm going to start with, I guess, I got to do that. Okay, great. So we're going to start with the northeast transect. And if you look at the LOX 135, LOX 135 is a monitoring station within the L40 canal. The concentration recorded in October for this particular station was 27 micrograms per liter. And the furthest station along the transect is LOX 139, which is approximately 4 kilometers away from the canal. And it had a TP concentration of 8 micrograms per liter. And you can see there's a sequential decrease in concentrations as you go into the marsh. That's due to the fact that we've got removal of particulate material. Any particulate phosphorus is removed by settling out. And we also have an uptake of the dissolved phosphorus that's occurring over that particular distance. And you can see that the LOX 139 concentration is pretty similar to the LOX 139. I keep mixing up the LOXs and the LOX, so forgive me if I do that. The LOX 139 is approximately similar to LOX 5 TP concentration, plus or minus given the analytical errors and so forth. So let's take a look at what that distribution looks like. So let me just make one thing also clear, that basically if you look at this transect from the canal into the LOXA 139 site, we have a threefold dilution in TP concentrations. So let's take a look at the northwest transect. Not click. We have a similar, maybe a little bit lower concentration at LOXA 104, which is monitoring station located within the canal. And again, as with the northeast transect, what we see is a decrease in TP concentrations as you move into the interior of the marsh, going to station LOXA 108, which is also 4 kilometers from the canal. We go from 21 micrograms per liter to 7 micrograms per liter, which is also a threefold decrease in concentrations. And the final transect that we're going to take a look at is the southwest transect, and that's bounded by LOXA Z0, which is a canal site, and it extends out to LOXA Z4, which is approximately 3 kilometers into the marsh. For this particular sampling event, there was no data collected at LOXA Z1 because when the crew went out there, it was deemed unsafe to land because it was a congregation of gators. And I do not mean UF fans, although that would be a terrifying sight as well. But again, you could see a decrease in TP concentrations from 19 micrograms per liter down to 6 micrograms per liter. So again, we're seeing a dilution effect of about threefold with TP concentrations for this particular event or for this particular month. Moving over to the conductivity data or the specific inductance data, what we can see basically is, just let me make one thing clear. When you see the headline or the header up above this thing, it says that the range is 77 to 696, but you can't see us. Well, actually, in here you can see a 696, but trust me, that's going to be including the transect data as well. I just haven't brought it up. I want to deal with the marsh data first, the compliance stations first. So in this case, we do see a specific inductance range of about 77 microsiemens per centimeter to 696. So the 77 occurs at LOX 10. The 696 occurs at LOX 15. By the way, LOX 15 had a 7 microgram per liter TP concentration, but it's affected by the canal. So one thing to keep in mind. If we look at LOX 8, it has 144 microsiemens per centimeter. And what we notice is all the stations that are on the boundary or the perimeter of the refuge are exhibiting higher specific inductance levels because of their influence from the canal. LOX 3 is sort of an odd child because LOX 3 is isolated and its specific inductance tends to vary based on evapotranspiration and rainfall more than anything else, as do most of the interior sites, especially LOX 8. I believe in one of the studies done by USGS, LOX 8 was identified as the most natural site in the refuge due to its distance from the canal and extremely minimal influence from any impacts from the canal. So when we bring in the, again, I keep forgetting to use the arrow key. When we bring in all the transect stations, we can now take a look at how these specific conductance levels vary as we go from the canal into the interior. So we'll start off with the northeast transect, and what we see is basically high specific inductance in the canal of 590, And by the time we get down to LOXA 139, that level of ionic material, dissolved material in the water column has decreased down to about 240 microsiemens per centimeter. When we take a look at the northwestern side, we see a similar reduction, except the reduction on the northwestern side is like 8-fold. So that basically tells me that there's not any penetration of the canal water into the interior portion of the marsh. When we look at the southwest transect, we are seeing the same thing. We're seeing basically very high specific inductance that are associated with the canal. And by the time we get into the interior, we're down to 131. So we've got relatively high dilution occurring as we move from the canal into the marsh based on conservative ions. So let's take a look at the February data. So when we take a look at the February data, the first thing that'll jump out at you, if you've been looking at it, is that we don't have any data at LOX 3. The reason there's no data at LOX 3 is because when the crew went out and they flew to LOX 3, the station was ponded, basically isolated from everything else, so it was not a representative station, and no sample was collected. The other thing to mention is that when we get into in situations where stages start to get lower and we have dry conditions, which you expect to have in February, we may find that the slew of parameters that would typically be collected are not collected, but what is being collected are the primary parameters for compliance purposes. So in this case, it would be TP, specific inductance, and any kind of hydrolab measurements or YSI measurements, whatever multi-parameter you happen to like. But other parameters such as ions and potentially dissolved phosphorus would not be collected due to limitations in water depth. So when the water depth gets below 20 centimeters, the focus is on total phosphorus and in situ measurements. So when we look at the February sampling, what we notice basically is that there's a range in TP concentrations from 7 micrograms per liter to 21 at LOX 8. So the 7 occurs at LOX 15 and at LOX 12, but we have a 21 right in the middle of the refuge. Interestingly, those stations that are closer to the canal all have lower TP concentrations than the interior of the canal, of the marsh, excuse me. Especially when we look at stations like LOX 15 and LOX 6. So what happened with TP concentrations as we move from the canal into the marsh? Well, let's take a look at the transect information. The northeast transect provides us with a 22 microgram per liter concentration in the canal. And what we see is a decrease in concentrations, a twofold decrease in concentrations by the time we get to LOX 139. The concentrations are down to 10. And the closest interior station to LOX 139 is LOX 5, which is at 8. If we take a look at the northwestern side of the transects, the northwestern transects, we see that we have very limited stations that we can look at at the changes in TP concentrations from the canal into the interior. And again, that's due to the fact that we had drier conditions, and for several of the stations, like Loxa 105, Loxa 106, and Loxa 108, the water depths were actually less than 10 centimeters. Loxa 107 had a pounding issue, which basically meant it was isolated from everything else, and therefore no sample was collected. But we do have a TP concentration at Loxa 107U, and we can see that based on what the canal concentration is of 24 micrograms per liter, we see a drop in TP concentrations down to 7, which is approximately a threefold decrease. And I'll just leave it at that. It's a threefold decrease. When we take a look at the southwestern transect, we see pretty much a similar thing, maybe a 2.5-fold decrease in TP concentrations as we move from the canal into the interior towards the marsh. And you can see that Loxa C4 has a concentration of 7 micrograms per liter, not different from Lox 12. So let's move over to the right side of the slide, where we're looking at specific conductance. Now, the first thing that we see is that the specific conductance ranges are slightly higher than they were in October. The ranges are from 131 microsiemens per centimeter at, let me see, where did I put the Lox 10, yes, and 579 at Lox 6. Remember what Lox 6's TP concentration is. It's 8. And yet it's got pretty high specific conductance, which means it's interacting with the canal. Now, what we're seeing in the interior, we're seeing also slightly elevated specific conductance, but then again, that is something that typically occurs during the dry season in the refuge as evapotranspiration dominates over rainfall. So we are seeing evaporation occurring, which basically means that all the ions in solution are creating a higher concentration as the volume decreases. The mass is conserved, but the volume decreases, therefore the concentration goes up. And in this case, we're seeing specific conductance at Lox 8 of about 223, and the surrounding stations have very similar specific conductance. If we take a look at the transects, again, we're seeing a decrease in specific conductance going from 900 at in the canal, in the L40 canal, down to 381 at Loxa 139. And basically, that is approximately a threefold decrease in concentrations, or in specific conductance. When we take a look at the northwestern side, we go from 766 down to 213 at Loxa 107U. Again, approximately a threefold decrease in specific conductance levels. And we observed the same type of decrease in specific conductance when we look at the southwest. Interestingly, if we look at Loxa 104.5, almost sounds like a FM station, doesn't it? We see that the specific conductance levels are higher than in the canal. So one of the reasons that this may have occurred is because of evaporation. The concentration, the area there got concentrated as water evaporated. We see a similar, we have a similar observation at Loxa Z1 as well. All right. So this slide basically looks at the historical information for the transects, the 3 transects. The northwestern transect for SDA-1 West, the southwestern transect aligned with SDA-1 West, and the northeastern transect aligned with SDA-1 East. The top plots provide us specific inductance levels, and the bottom plots look at geometric means. So each one of the points that you see along the line, or for each one of the stations, is the median of the period of record annual geometric mean for that location. The shaded areas provide the 25th and 75th percentile of the annual geometric means for those locations. One of the things that we see is if we look at the northwestern transect, we see a very steep decrease in specific conductance to about 2 kilometers in, and after that we see a leveling off of the specific conductance levels. We see a similar occurrence at the southwestern transect, where we see concentrations of around 800, concentration levels of about 800, decreasing down to below 200 microsiemens per centimeter within a 2-kilometer distance. With the northeastern transect, we see something a little bit different, but nevertheless, we do see a decrease in specific conductance as we move into the interior, although the changes in annual geometric mean specific conductance vary much more than they do at the other 2 transects. Below, we see the annual geometric mean. So we see the medians of the annual geometric means from the canal into the refuge, and one of the things that we notice is that basically within 1 kilometer from the canal, we're seeing concentrations at or below 10 micrograms per liter, and about 2 to 3 kilometers in, we're down to 7 to 8 micrograms per liter. Okay, well, how does this compare with the October event? So the little red dots, I hope all of you can see them for those that are following along on the screen, and those that are looking at your plots, it might be a little bit harder because, on the handouts, because there are 2 data points that are shown, the October and the February, but let's talk about October. What we're seeing with specific inductance in the northwest transect, we're seeing it's pretty much following the trend that the historic data is showing. Same thing in the southwest transect, and pretty much the same in the northeast transect, although a little bit more towards the upper boundary. When we look at TP concentrations, again, we're following the same trend that we've seen the historical data do. There's some bopping up and down, but typically it's pretty much the same trend. Same thing with the southwest transect, and I think we can say the same thing with the northeast transect. So we're seeing consistent dilution of specific inductance and TP concentrations as we move from the canal into the marsh. When we add the the February data, again, we're seeing pretty much the same thing. The only differences we see is some increases at some of the stations that we've noticed in the previous slide. We were looking at stations that are within the marsh but very close to the canal, have higher specific conductance levels than you would expect. When we take a look at the northeast transect, again, we're seeing this decrease. It is a little bit outside, actually some of it are outside of the 75th percentile of the annual geometric means, but remember, these are annual geometric means, and the points that you're seeing here are monthly data. And we're seeing decreases in TP concentrations. Their decreases are, 2 to 3 times from what the canal concentrations are. Next thing we wanted to do was take a look at how TP concentrations have been distributed over the entire refuge from the period of February 2007 to March 2025. So I broke up the stations into 3 sections. I know there are papers that look at transition zones and so forth, but I chose to do it in 3 sections. It was just going to be a little bit easier to plot the information. So we have the canal segments, both east and west. The West Canal comprises of 2 stations, LOXA 104 and LOXA Z0. The eastern side has LOXA 135. And the stations that you see in between are what their location is to proximity to the canal, to the closest canal. So everything that is furthest away from the canal here in the periphery is actually that, it kind of represents their distance from the canal. Same thing with respect to the eastern periphery stations and the interior stations. So everything on the edge of the interior stations like LOXA Z4, LOXA 139 are closest to the canal, and as we get to the interior, we're further away from the canal, LOX 8 being in the center of the refuge. So one of the things that I've identified here, Jody did the same thing in one of the other plots, was the range of the compliance equation, the working range of the compliance equation for TP concentrations, 7.2 and 17.5. 7.2 micrograms per liter represents what the compliance equation calculates at a stage of 17.14, and 17.5 is what the compliance equation determines at 15.42. So when we're looking at this, we're seeing that the TP concentrations are decreasing as we move into the interior of the marsh. And one of the things that kind of stands out is that LOX 8 has a much wider range of TP concentrations than all of the other interior stations, and frankly, some of the periphery stations as well. And if we look at the median concentrations from the canal to the nearest interior station, so that would be LOXA Z4 or LOXA 139, we see a 3.2-fold decrease in TP concentrations. Okay, so let's take a look at where the October data falls on this plot. And right now, what I'm showing here, red symbols, they're diamonds. They show what the concentrations for each one of these stations were during the month of October. Those stations that don't have a symbol associated with them, a red symbol, basically we didn't have any data. So we can see that most of the data falls within the boundaries of the box plots. They're not on the whiskers, they're more in the section of the box plot. So when we look at the February data, we notice typically we're seeing data that is pretty similar for the period of record, except for LOX 8. Even the LOX 11, LOX 13, LOX 9, while they're not within the box, they're on the whisker, which basically would not mean that they're in an outlier mode, but LOX 8 definitely stands out from all the other stations. Next thing we want to take a look at was how does conductivity change? How did the conductivity change over the period and what the distribution was at each one of the stations? So one of the first things I want to show is basically we've got a class 3 standard of 1275 microsiemens per centimeter. I use a 200 microsiemen per centimeter reference line to annotate the maximum conductivity that you typically find in a range-driven system, which basically the refuge, the interior stations of refuge are definitely range-driven more than anything else. And what we see is we can see that there's an abrupt decrease in specific inductance as we move from the canal into the interior, especially if you look at these periphery stations. Now, Lock 16 and Locks 15, well, Lock 16, for instance, is very close to the canal, and you can see the variability in the data. Locks 15 is practically next to the canal, as is Lock 6. Remember, those two stations have some of the lowest TP concentrations, even though they're influenced by the canal. Typically in the south, we're going to see lower TP concentrations due to the migration of the water from the interior down. So that might explain the TP concentration. It doesn't explain why conductivity is so similar to the canal if the fresher water from the refuge is moving into that area. But anyway, what we noticed is basically that the Locks 8 data is pretty much similar to what you would expect for a range-driven system. And we can see that even on the western side, or eastern side, excuse me, we have a steep gradient with change in specific inductance. So if we look at the nearest interior stations to the marsh, again, Loxa Z4 and Loxa 139, what we see is a decrease in specific conductance from 5 to about 6-fold compared to the canal. Lox 8 exhibits a median concentration of 116 microsiemens per 7, which is 7 times lower than what you see in the canal. Okay. So now I'm going to show you what the October data looks like. And what we can see is that the October data apparently is a little bit lower in the canal than what we historically would expect. And remember, Jody said there was some rainfall events that occurred prior to October. That rainfall may have helped in diluting the specific conductance in the canal, both on the east and west side. Interestingly enough, Lox 15 has a really high specific inductance. You can see that that specific inductance is up on the top whisker. But when we look at the interior, the specific inductance level that were measured are not atypical for the interior stations. Next, we're going to overlay the February data, and we see that there are slightly elevated specific inductance levels for the February data. Again, we are in a drier period, and we expect to see some increases of specific inductance during that period. I believe that you can expect to see specific conductance increases or your conservative ion increases anywhere from 40 to 70% during the dry period within the interior of the refuge. So we don't have any evidence here that we are seeing canal intrusion. What we are seeing is more of normal cycling of evaporated water, which basically increases concentrations within the refuge, in the interior of the refuge, excuse me. One of the other things that we wanted to do was to compare the interior stations. So we took all of the TP and specific inductance data, and we did a Kruskal-Wallis test to determine whether there was a statistically significant difference between the stations. And the results turned out that there was a statistically significant difference, but now we needed to figure out which stations were statistically different from other stations. So we used the, boy, it's a mouthful, Steele, Wass, Critchlow, and Fligner test that did an all pairs comparison and identified which stations were statistically different. And the table below gives you a summary. Now, I know there were some comments, but I'll explain my rationale for doing it the way I did it. LOX 8 was statistically different from all the stations. So there was no reason for me to repeat LOX 8 being statistically different from LOX 7 because it's already identified in the first row. But what I did identify is that even though LOX 7 is statistically different from LOX 8, it is also statistically different from LOX 11 and 13, and LOXA 108 is also statistically different from LOX 11 and 13, and so is LOXA 139, on top of being statistically different from LOX 8. So if a station's not listed here as being statistically different, it was not deemed to be statistically different from any of the other stations. When we move over to the specific inductance, what we see is that LOX 3 is statistically different from all of these stations, which include LOX 8. LOXA 139 is also statistically different from all the stations, including LOX 8. And LOXA Z4 is also statistically different from all the stations, including LOX 8. On top of that, LOXA 107U, which is found to be statistically different from these three stations, is also statistically different from LOX 13. Now, why is LOX 3 statistically different from all of the other interior stations? Well, that station tends to dry out. It's very much affected by dry out, so its specific inductance is going to vary widely. LOXA 139 is on the edge of the interior data set, and it does have influence from canal intrusion. Same thing with LOXA Z4. LOXA 107U does have higher specific inductance than LOX 13, so therefore it became statistically different, but it's not statistically different from any of the other stations that are not different from, or that are different from LOX 3, 139, and Z4. Okay. We use the significance level of 0.05. I'm sorry I don't have the p-values, but if you guys are interested in p-values, I'll be more than happy to provide them to you. But I can tell you that there was substantial significance. It wasn't like 0.05 or 0.04 or 0.03. It was substantial, like less than 0.001. Okay, so the final, I hope I haven't bored you guys too much. The final set of slides, actually not even a set of slides, it's just my final slide. We took a look at speciation of TP for the two monitoring events. So we pulled total dissolved phosphorus data for each one of the stations, and we did a little bit of calculation. By subtracting total dissolved phosphorus from total P, we get particulate phosphorus. That gives us the particulate fraction, and we have the dissolved fraction. So when you're looking at these two maps, you will notice that below each station name, there is a value and a value in the parentheses. The value that is not in parentheses is the particulate fraction, and the value that is in parentheses is the dissolved fraction. So let's concentrate on the October 2024 event. And what we see is there's an almost equal partitioning between dissolved and particulates at all the stations within the refuge, about 50-50. I would like to say that we wanted to take a look at, well, we did want to take a look at what this partitioning was like in October for the transect stations. Unfortunately, we didn't have any data for dissolved P, so I could not give you any kind of a rundown as to what the partitioning of phosphorus was from the canal into the refuge. But the more important thing to keep in mind is that within the refuge, we see a 50-50, meaning that of the total phosphorus reported, 50% is particulate and 50% is dissolved. So let's take a look at February event. February event, what we find is that most of the stations have a 50-50 partitioning between dissolved and particulate. Lox 8, on the other hand, has a 14 part per billion or microgram per liter concentration of particulate and a 7 microgram per liter concentration of dissolved. Now, taking that into context, the particulate concentration at Lox 8 is higher than any of the concentrations measured at the compliance stations, just the particulate concentration. Okay, so let's take a look at how these concentrations are at the transects. And I'm going to have to get used to using the arrow key. I keep clicking on the mouse. And you know what? The time that I get used to it is when I finish the presentation. All right, so let's take a look at the northwestern transect. Let's look at the canal, Lox 135. We have 14 parts per billion or micrograms per liter of particulate phosphorus and 8 micrograms per liter dissolved. That's pretty similar to what you see in Lox 8, isn't it? But as we move through the transect, what we see is that both fractions start to decrease. Why? Well, the particulates are starting to settle out, probably uptake of the other phosphorus, maybe some dilution along the way as well. So what we're seeing basically is a decrease in both the particulate and dissolved as we move into the marsh. Unfortunately, Lox 139 did not have any dissolved P data, so I was not able to calculate that fractionation. Well, if you move over to the northwestern side, again, lack of data. I wasn't able to do any calculations, but interestingly, when we look in the canal on the northwestern side, we see a 50-50 partition between particulates and dissolved. Okay, moving down to the southwestern transect, we did have data. And again, we're seeing a partitioning that's about 50-50 between particulates and dissolved. And as we move into the marsh, we see a decrease of both. So we've got settling of particles, uptake and dilution of dissolved fractions. So based on the analysis that we performed and looking at the relationship between TP and specific inductance, looking at the partitioning of TP data, it appears that the concentration that we saw at Lox 8 is not affected by canal intrusion, but some localized activity may have caused some of the higher particulate material to be detected at the site, to have occurred. It could have been alligator activity, airboat activity. I don't know what the activity was, but it's amazing that all of the surrounding stations have practically a 50-50 partition between dissolved and particulates, except for LOX 8. Now, before some of you, well, look at LOX 11. Look, LOX 11 has a dissolved constituent that is below the PQL, so it's anybody's guess what that concentration is. It could be 5, it could be 4, it could be 3. I'm not going to dwell on LOX 11. I'm dwelling on the ones that we can see some good differentiation between the dissolved and particulate. So at this point, I'm going to hand over the presentation to Jody. Thanks for your attention.
Thank you very much, Nenad. Okay, so this concludes our evaluation of error for the February 2025 LOX 8 sampling event. So based on this evaluation, we ask the question, is the observed LOX 8 TP concentration that resulted in the February 2025 excursion anomalous and therefore not representative of interior marsh conditions? So just to recap, we indicated that the LOX 8 February 2025 data met the field sampling and laboratory compliance assurance tests. We pointed out that high TP at LOX 8 is observed historically, however, is observed at lower stages than the February 2025 stage. And at the February 2025 stage, LOX 8 historically, the TP observed ranged from 3 to 13 parts per billion. And in the February event, the TP observed was 21. We also pointed out that the stations surrounding LOX 8 do not share similar high total phosphorus concentrations. And further, LOX 8 TP concentration was 8 parts per billion higher than the next highest compliance station. For example, at LOX 13, the level observed was 13 parts per billion. Additionally, LOX 8 exhibited the highest particulate phosphorus concentration at 14 parts per billion of the surrounding interior stations, as well as the transect stations located within the marsh. We also presented that the stations surrounding LOX 8 do share similar specific conductance levels and were lower than the transect stations. This is suggesting an apparent dilution of the canal water. Transect data indicate that TP concentrations reached background levels within 1 kilometer into the marsh, and LOX 8 is located approximately 7 kilometers away from the most downstream transect station. And finally, LOX 8 TP is statistically different from all the other interior marsh stations' total phosphorus for the long-term level period. And for these reasons, the LOX 8 February 2025 sampling event is suspicious, and this evidence suggests that the data is not representative of interior marsh conditions. So we wanted to provide a figure showing what the long-term trends are for the monthly 14-station geometric mean total phosphorus. Seasonal Kendall statistical trend was applied for the long-term level period, and the negative send slope that I'm highlighting on the slide suggest a decreasing trend toward the goal of 7 parts per billion. However, this trend is not statistically significant, as highlighted on the slide. You will also notice that there are 11 excursions, if you count the red dots, out of the total of 209 sampling events. This results in a 5% excursion rate for the long-term level period. So in summary, there were 2 excursions observed in the previous 12-month period. The October 2024 event coincided with the upper stage range of the long-term level equation following a rising stage event. In February 2025, we presented evidence of anomalous data at Locks 8 and a lack of evidence of canal water intrusion driving the TP at Locks 8. And this is based on stage, specific conductance, the surrounding station's total phosphorus and phosphorus speciation. We also presented the 14-station geomean. Total phosphorus concentration trend is not statistically significant. However, the trend line is hovering around 7.2. And the long-term level period has an excursion rate of 5%. So to deal with the Locks 8 anomalous data issue, one possible outcome is to launch a Locks 8 data anomalous investigation. And these are just some ideas that we had, and we're open to further discussing these. One is to install wildlife cameras surrounding Locks 8 to investigate whether or not there's any disturbances or interferences from wildlife. We actually already launched this effort. We've done a ground reconnaissance to kind of figure out where those cameras could be positioned. Secondly, we could implement continuous monitoring with sondes. So these are installed in the field, and we get continuous data coming in as opposed to our monthly sampling where we only go out once a month. And this data we can obtain on a real-time basis what the specific conductance is, what the turbidity is, what the temperature is, dissolved oxygen, and pH. And another thought we had was to implement some alternate sampling at Locks 8 within 200 meters to determine if Locks 8 is being sampled in a location that may not be representative of marsh water quality. The reason why we chose 200 meters is because under rules, this is the distance where you could say that you have you are measuring data that is representative of the same station. And for the marsh, as you know, we don't have a fixed point that we sample at every month. The helicopter lands, the sampling crew has specific rules that they're required to follow. For example, they have to walk towards the front of the helicopter, and there may be certain conditions in the field that may cause them to not land in the exact location every single month. So we thought that during these monthly sampling events, staff could sample at the Locks 8 station that's used for compliance, but also sample at another station, and we can do some sort of side-by-side comparison to see if we're seeing any differences. We can review that information and determine if Locks 8, warrants possible relocation of that station. And that is all we had for you today. Thank you very much.
Thank you, everyone. What you just presented certainly is the result of a significant amount of work you guys did to look into what's going on at Locks 8. Do the reps have some questions or comments or discussion at this point?
This is Donato. I do have a number of questions for discussion, but I see Bill Walker's hand is up, and it's been up for a long time, so I'll let him go first.
Yeah, unfortunately, I kept creating new questions as it went along, and a lot of them were subsequently answered. On Jody's graph of the trend in the geometric...
Can you give us the slide, Bill? Give us the slide. She has it up, never mind.
Yeah. Yeah, there's a slight decreasing trend, not statistically significant, but if you look at the data prior to that, the marsh concentrations were quite a bit higher back when we were having trouble meeting the interim limits. So Ned had stated that the interior marsh is rain-driven, but that wouldn't explain the long-term trend going back to 2024. So I think there is a response to the load reductions. It's just kind of flattened out since 2007. And then on Netted's last slide, the map. Yeah, are these labels switched? Because you have, like for October 24, you have for LOX 8, what, 7 parts per billion, 3 plus 4. But for February, you have 14 and 7. And I thought, that seems to me, that looks more like the October 24 values.
The 14 and the 7 add up to the 21, Bill, for February. I don't think I'm following the question. Can you state it again?
Okay, the February event, all right. All right, so I have, okay, fine. February event is the one we're looking at here. All right, not the October. Yeah, the only other one is kind of picky, but Netted showed box and whisker diagrams for the TP, and
Which ones, Bill?
go back.
The full?
I don't know.
The full?
Well, any of them. I'm just curious about that presentation because the data tend to be log normally distributed. And I realized that the 25th and 75th percentiles are non-parametrics. It doesn't matter whether you transform or not. But what about the whiskers? In other words, if you plotted this on a log scale, would that change the distribution of high values relative to the whiskers?
Well, visually it would change it. Numerically it wouldn't change it. Just a comment on log normal. My experience with looking at the interior stations actually checking for log normality is it's kind of hard to find it, especially LOX 8. You could take and transform the data into log values and then run a normality test on it, and it still deviates from normality. So I think people tend to use log normal very liberally without really checking to see whether the entire data set is log normally distributed. So I think looking at box and whiskers gives you a much better idea of the distribution of concentrations because we are not tied to a distributional assumption.
Mm-hmm. Okay, but if you look at the 14 station geometric means that we use to derive the equation, the scatter at the low stage range was much higher than the scatter at the high stage. So to me, that would suggest that the log normal is more accurate. I mean, we looked at that when we derived the equation, but I think that's kind of a minor point.
I think I would tend to agree with you, Bill, but if you look at the data sets that you had when you derived the equation, it's much more limited than looking at the monthly data, 209 data points is a geometric mean, which basically is 209 data points are derived from at maximum 14 stations. So we have a lot more data now than we did when we derived, and that distributional assumption being a log normal distributional assumption being correct may not be valid with this large of a data set. So I think we may be comparing apples and oranges at this point, but I understand where you're coming from.
Okay, I understand what you're saying. And the only other comment I had was on further investigations. And I'm wondering, I take it you don't have turbidity measurements at these sites or suspended solids?
So we just, to took
Oh,
a
you do
look.
have a trigger.
Well,
You do
we
have a
did
trigger.
historically, and that is a parameter that we just revamped we took a look at all of our overlapping monitoring programs for the refuge to try to assure that there's a consistent set of parameters that are monitored across the different programs, the refuge compliance stations, the transect stations, the LOXA stations, to assure that there's a consistent set of parameters being monitored. And through that effort, we added some parameters at some stations and inadvertently dropped parameters at other stations. And we are taking a closer look at that, and we'll be reinstating turbidity or total suspended solids at the stations where that dropped off.
Okay. What about chlorophyll? Sometimes you find in the marsh when, it's an isolated area, you can get algal blooms, and that tends to, cycle back and forth between the sediments and could be responsible for higher TP concentrations. So I suggest that you look at chlorophyll as well.
Okay, we could take a look at that.
Thank you. That's my questions.
So Jody, in response to, or follow up on Bill's question where you just responded about adding more parameters. So for the LOXA stations, we now have the full suite of parameters?
Not currently. That is something that we're going to be working to reinstate, but not.
It never had it before. It was just like TP and sulfate, and it was a minimum sampling for the LOXA stations as a part of the 4-part test, yeah.
Okay, I thought you were talking about the
ones along
compliant. I thought you were talking about the compliance stations. Yes, for the LOXA stations, the LOX compliance stations, and the transect stations, we want to assure that across those programs we have a consistent set of parameters. So if it was never at the LOXA, we will be adding it. Just like TDP was never at the transect stations, but we now have it.
Nice.
So we're looking into all of those things.
And Donato, I didn't quite catch what parameter you mentioned.
I didn't say a specific parameter, but there were a very limited suite for the 4-part test that were incorporated into the monitoring for the transects downstream of the STAs, and so they didn't have all of them. It was just exciting to hear that we're elevating those up to the rest of the level of all of the monitoring.
Okay, thank you.
No, what I did, I said TP and sulfate, and there was probably chloride. There was something else. I don't remember now, sorry. So Nanette, I think this one is to you, but I think Jody presented the slide. Slide 9. You guys did, okay, so it's actually about the sensitivity analysis. And you used this pre and post month for the February event to do the sensitivity analysis. But then on the next slide, you identify that at the stage of the February event, you had a range of 14 to 13 parts per billion. Why didn't, or was there any consideration to use that range, given that would have been consistent with the stage argument that's being made through most of this presentation?
That's an excellent question. We did look at that. We just did not put it on the slide. If we substituted 13 into the 14 station geomean, that would have brought it to 9.1. Right, Chelsea? If we
I don't remember the exact number, but okay, I cannot remember the exact number, but I knew that if the TP was up to 15, we would still meet the long-term level. So the 21 parts per billion was, it seems to me, was definitely an outlier. And if you pick any number in that month, any station, or even prior month or after that month, the following month, we would still meet the long-term level for February.
Thank you, Chelsea.
Thank you for that response. So in the past, we have had discussions about labeling independent samples as outliers. And I struggled, given that we only get to take that one sample each time. I struggle saying that they're outliers when they just represent the pool of data that we're getting from that location under varying conditions. I couldn't possibly go back and look through all of the notes to talk about how we concluded that discussion, but it seems like we should avoid demarcating these samples in that manner. I don't know how that benefits us, because the data, they still exist. They're still there, and that's what's actually in the field that's being observed. So marking it as an outlier, I don't know how that helps. I do know it goes into the description of trying to call it an anomalous event, but it's there. So there are events that are going to drive it to be available, and we're going to see that in the future. Nanette, one of the comments that you made was at the fringe of the system, most of the particulate phosphorus is being removed before it moves into the marsh. And I definitely agree with that concept. And because we are seeing twofold particulate phosphorus at Lox 8, I do think it deserves an investigation. So I like where you guys went with the investigation concept. So I definitely want to see, I don't know if any of that is going to tell us how that phosphorus gets there, though, the things that we put on the list, right? I want to definitely see the monitoring, but I'm not clear how that leads us to understanding how that particular phosphorus got there. Maybe the cameras will help us see some animal, if it's the alligators, but I don't know. And then, so you mentioned Lox 8 wasn't sampled because it was ponded. What does that mean?
Lox 3.
Sorry, Lox 3 wasn't sampled because it was ponded. What does that mean?
Basically, it means that the station that they go and monitor has a pond around it, and everything around that pond, outside that pond, is dry.
So does that mean it was below the 10-centimeter sampling depth?
No, it just was isolated from everything else, and it wasn't representative because it was not representing what the concentration in the marsh was. It was representing what the concentration in that ponded area. It's just like, you see a pond outside. So they don't sample when there's a ponding that occurs around a station where it's isolated from the remaining portion of the marsh. It's not continuous connection to the marsh.
I appreciate that. I'm old and have not been out in the field to do this sampling since 2006, but I don't remember that being as part of the selection of sampling the protocols. Did the FQ, the field quality sampling guide, get updated with that document? Is that documented now so we know that's the criteria?
Actually, that is part of the process for the field, and you even will see comments in our database near structures where something may not have been collected because it was what they call an isolated pool. So it's not representative of the water body, but we'll be happy to give you a copy of the field sampling manual if you'd like it.
I haven't seen that for decades. The other one is you point out that there are ions out there, and I don't think alligators would explain that. And you didn't, so you got the specific conductivity, and when I look at that figure that you have with the box plot, it does show that it's above the area that you called outliers. I'm not clear how that would, I know we concentrate when the water levels get lower, but the ions had to be there to be concentrated, so.
Okay, so. Yeah, okay. The interior of the marsh is dominated by sodium chloride. And the reason it's dominated by sodium chloride is because it's rain-driven. And rainwater in Florida has seawater aerosols associated with it, which are dominant sodium chloride. So the area in the marsh, in my opinion, based on looking at some of the ions, has a ionic signature that is different from the transition stations and the canal. And any of the ionic activity that we see in the central area of the marsh is just basically, they're conservative ions. As the water levels go up, the concentration goes down. As the water level goes down due to evaporation, recession, whatever, the concentrations go up. So what we're seeing with the conductivity is basically the evapotranspiration portion of the cycle being more active than rainfall, and therefore we're seeing a concentration of the ions. One of the ways you can look at whether it's rain-driven or not is to look at pHs in the refuge. When you get into the central portion of the refuge, the pHs are low. Now, there are two reasons why the pHs are low. One of the reasons is that there's a lot of humics due to decomposition of organic matter. The other is that rainwater has a low pH. And there's a natural way of having a low pH, which is you have CO2 in the atmosphere. CO2 dissolves, creates carbonic acid, lowers the pH. We also have another problem that we have to deal with every day, which are cars. Internal combustion engines generate nitrous oxides. Nitrous oxides get into the atmosphere, and we get nitric acid, another acidic portion of rainfall. It's not only, let me be very clear, it's not only internal combustion engines. Whenever we have lightning strikes, we generate nitrous oxides because, after all, our atmosphere is nitrogen dominated. And so when we have lightning strikes, we get nitrous oxide produced in the atmosphere. Water vapor mixes in, or water droplets, we get nitric acid. So those are affecting the pH within the central portion of the refuge. If you look at the compliance analysis for alkalinity in the refuge is consistently below the 20 milligram per liter for alkalinity because it has no buffering capacity. It doesn't have a lot of bicarbonates or calcium compared to sodium chloride. So the ionic composition in the refuge is basically alternating between wet and dry seasons. As we get, when we get to the wet season, we get a concentration of ions, the specific conductance will go up. And when we get to the wet season, we get a dilution of ions, and the specific conductance goes down.
Thank you for that response. What I'm trying to get to is, I didn't hear you guys qualify LOX 8 from a conductivity perspective as anomalous.
Excuse me?
I didn't hear you guys qualify LOX 8 from a specific conductance perspective as anomalous. So I'm trying to understand, do you think that is abnormal for this conductivity, or just the phosphorus was abnormal?
I don't think that the specific conductance is abnormal, that what we see at LOX 8 and some of the other locations. LOX 8 is a little bit higher elevation than some of the other stations around it, except for LOX 5. I think LOX 5 is at a higher elevation. So it's going to be affected by evaporation a lot more than some of the other stations. So I don't think it's outside of the realm of typical concentrations, typical conductivities that we see at LOX 8. They do occur because we do have dryouts occurring in the area. So you're going to have higher conductivities.
And could I just interrupt for a second? I know Bill put his hand back up, and I bet Donato has more questions, but I'm being asked if we could take a 5-minute break, because I drank too much of my coffee already. So if you guys don't mind, we'd like to take a 5-minute break and be back in 5 minutes.
I'm good with that, thanks.
Okay, we're back. If you could please put us back into Zoom, that would be great. Thank you. All right, thank you everyone for your patience while we took a quick break. And I apologize for having to interrupt you, Donato. So you were in the midst of a bunch of questions and discussion with Ninit, and your person, Dr. Walker also has his hand up. So if we could kind of pick up where we left off, that would be great.
Yeah, nature does call. Okay, so yeah, I see Bill raise his hand, so I'm gonna give him the floor again for a few seconds.
Okay, thanks. I mean, this idea about the ponded areas being somehow specially considered in the sampling protocol, I don't recall that. I think Donato mentioned that they're part of the refuge. I'm sure there are ponded areas throughout the marsh, you know, and under certain conditions. And it was used in deriving the compliance equation. And I do support exploring the sites within 200 meters of Blocks 8. But it's just sort of, I don't think there's a basis for excluding it altogether or characterizing it as just because it's different from the other stations. Like I said, it's not, those types of areas are located throughout the refuge. So, not throughout, but interior sites. And that's it. Oh yeah, the other thing was on this chlorophyll business. I recall that there was some research done by the agricultural community on that topic, although they were looking at canals, but they found that when there was an algal bloom in the canal, the sediments went anaerobic, and that would trigger phosphorus recycling from the bottom sediments. So that's another reason to at least explore, you know, taking chlorophyll samples. That's it.
Okay, thank you. Devon, could you please unmute the microphone at the podium?
Testing. Okay. Just want to say thank you, Dr. Walker. Yeah, that's something definitely worth looking into.
Okay, so on slide 16, Nanette, you were explaining canal water movement into the marsh, and you pointed to locks 15.
Yes.
What you were describing made me have a feeling or a pretty strong sense that we can't really describe canal water intrusion in a linear or even a log perspective. It's more complicated than that. Would you agree? Or
Could you repeat the question?
can we go to slide 16?
Well, we are on slide 16.
Oh, no, this is not the one. It's the one with the map where you showed the 6 something for the...
Hold on. This one? Or do you want to look at, this is what, February? Or do you want to look at October? Here's October, it's got a higher specific conductance.
Right, and then you showed that it wasn't as high in the marsh pretty much anywhere else. I see it's pretty high over at Locks 4. Does this, from your perspective, does this suggest that canal water intrusion into the marsh is not a linear dynamic or not even a log dynamic? It's more complicated than that?
This to me shows that, well, first let's put things into perspective, okay? The water movement from the refuge is from north to south. So obviously, as we go through the entire refuge, you're gonna have some uptake of nutrients before it gets down to the southern region. So we would expect TP concentrations to be lower if all that materials making it down. But what is really strange is that we know that the interior of the marsh has lower specific conductance, and we're not really seeing that abrupt change in specific conductance at Lock 7. It's reflecting the canal specific conductance. So there is canal intrusion to that station with respect to the dissolved materials, major ions and other dissolved materials, and yet we see low TP concentration at that site. So we're not seeing a dilution of the specific conductance. The same can be said about Lock 6. Lock 6 has historically had lower TP concentrations, but it's also had higher specific conductance than, let's say, some of the interior stations. So one of the things that we see is I've looked at specific conductance in the refuge by doing a whole bunch of different contour maps across the entire refuge with specific conductance using the LOXA data that you guys did in the early 2000s. And what I'm seeing is a very quick change in specific conductance from the canals into the interior. I mean, there's a very quick drop. So that, to me, would indicate that the intrusion of canal water into the interior, especially to Lox 8, is practically minimal to, at best, minimal to non-existent. Now, the way to really go ahead and understand the dynamics of specific conductance in the refuge is not just to look at specific conductance. It's actually to take a look at the components of specific conductance, meaning the major ions, and to determine whether the composition with respect to major ions in the interior is vastly different from the composition of major ions in the canal. Well, there are several ways of doing it. The problem is getting the time to do it, to get the data put together, and to be able to graphically present the difference. It's not an impossible thing, it's just time-consuming to do. But that would give us a better understanding of the intrusion, if you will, of canal water. If we're seeing vastly different composition of water in the interior, that would argue against the intrusion of water. If we're seeing a change in the ionic composition as you move from the canal into the interior, and then you could take a look at it at various specific conductance levels. How does the composition at a particular station change based on specific conductance levels? Are we seeing any alteration? As we get to the higher specific conductance level, has the composition changed or has it remained the same, but the only thing that's changed is the concentration has increased? That, I think, would be a way to get a better idea of impact of canal water on the interior.
I'm hearing some additional things going on that slide for actions. Thanks, Nanette. The next question.
Can I ask a follow-up?
Please.
Sorry, I don't know how to raise my hand in person. I wanted to just follow up on that because Donato was hitting on a question that I had written down. So we focused really heavily and done a great analysis of the impact at the stations, but that's assuming that the water is flowing through those stations. Have you considered that maybe there are other pathways of canal water or some of those components moving into the interior that aren't necessarily passing through those stations sequentially?
I'm not sure I can answer that question directly. Again, the tracer in this case, to be able to answer that question, would have to be something that's conservative, that is not going to be biologically affected. And I've already spoken to Donato a couple of meetings back that there are some major ions that are affected both biologically and thermodynamically, if you will. So I think we would have to look at the speciation or ionic composition to get a better idea if in fact there are alternate pathways that is bringing canal water into the interior. Again, I'm going to stress, if we find that the ionic composition does not change over a vast range of specific conductance, then the idea of water intrusion or canal intrusion at particular stations can be put to rest. We are not seeing canal intrusion. We are seeing just dynamics due to rainfall and internal processes. As we get to those stations, they get closer to the canal, and if we're starting to see a particular ionic composition under high stages, high conductivities, and low stages, let me just say low stages, and then as we go to high stages and the ionic composition changes, then we can make some determination as to whether we are seeing an impact or any kind of canal intrusion, or are we seeing effects of rainfall, where it's bringing, or movement from the interior of the marsh out to where it's bringing a different composition, and that composition alters that station's compositions under certain conditions. So I think looking at TP, while it is the focus, we have to understand that that TP may not come from the canal, it may come from internal cycling. And I don't know of any other way to take a look at it. I think looking chemically, I'm a chemist, so chemically I'm gonna look at what's the composition of the water like.
And I actually have a question based on everything I've heard so far, but I can hold that. Mr. Barquette, your hand is up. Did you have a comment or question?
I did, yes. It's a very interesting presentation. I'm anxious to see how the notes are going to read of this meeting. It was quite lengthy and quite complicated. But I want to come back to basics. There's a difference between saying something is an anomaly and saying something is erroneous. And I urge the council on the phone to focus on the language of the settlement agreement and for the TOC reps to focus on the questions you have to answer. There's nothing that I heard today that says to me that the data was erroneous. And if that's ultimately the conclusion of the TOC reps, then I think you need to evaluate the department, both of Environmental Protection and the Department of Justice need to evaluate as they review the settlement agreement, whether something needs to be done, and if so, what. And in that regard, I think all the discussion today may bear on remedies, but it certainly didn't seem to me anyway to bear on error. And I listened very, very carefully. So I just share those thoughts with you. I know you have to consider this a bit more and evaluate it a bit more, which I always encourage, but it doesn't seem to me that you're focused on error as much as you are focused on what needs to be done. But those are preliminary thoughts. I haven't made any final judgments. But based on what I heard today, those are my preliminary thoughts.
Okay, thank you very much. I'm just curious because I've heard algal blooms mentioned a couple of times. Have we noticed algal blooms to some certain extent within the refuge?
We don't monitor algal blooms, but we do monitor in some ways a lot of other things, and that is something that I would just bring to light at this point is I think You mentioned that there was only 5% of the samples have been non-compliant, and, which is great, but we have noticed ecological effects on the ground, not so much algal blooms, but we see changes in periphyte, and we see changes in cattail, the spatial extent of cattail and willow and other species that we would not normally find especially at interior sites in the refuge. So, in light of seeing those impacts, we are concerned, even though it's a small percentage and it doesn't happen all the time, we are seeing impacts that could be related to some of these dynamics.
Thank you.
And Ned, this is my last question. Slide 17, you mentioned.
Wait, let me get to the slide.
Okay.
Okay.
So you mentioned, you gave us an explanation for why 139, A139 was significantly different, and it seemed like you were suggesting it was because it was heavily canal influenced.
No, I wasn't suggesting heavily. I was suggesting that it was canal influence.
Okay,
It had some canal influence to it that the other stations don't. Therefore, it's got the wider range and specific conductance.
And that's my question. So we have 3 stations, or a couple of stations closer to the canal than that. Why wouldn't they have a similar response?
Well, I didn't plot those stations that were closer to the canal.
Ah, good point.
I did the interior stations. The ones that I deemed interior, the ones that are greater than or equal to 3 kilometers from each of the canals.
How did you deem that?
Excuse me?
How did you deem the 3 kilometer threshold?
That 3 kilometer threshold was based on when we start, the 3 kilometer threshold was based on when we start seeing TP concentrations dropping from the transects, dropping to below 10 micrograms per liter. So I identified those stations where they were at or below, or at or further than 3 kilometers from the canal. That's the way I deemed it. I mean, it doesn't matter how I deemed it. You could break it up into the same type of stuff that you did and others did, where you have transition zones and so forth. I think the end results are going to be the same. It's just basically grouping the stations however you want to group them.
I appreciate your responses. I think the presentation was excellent. I definitely appreciate all the work that was put in. Oh, Bill has his hand up. I'm sorry. One more question, Bill?
Yes, I agree with Donato. These have been some excellent presentations and discussion. Ned had mentioned that there was a sharp drop in the specific conductance at L8 back in the early 2000s. I think that could easily be explained by the diversion of the inflows from S6. If you could pull up that map again.
Which one, Bill?
Not your last map.
The last one, the very last one, okay.
Yeah.
Okay,
Well,
hold on.
the map, there you go.
Just give me a break, let me just get, okay.
Okay. Yeah, well, you see, actually, the one with the transects on it shows it better.
Okay.
But
Hold on. There you go.
yeah, I mean, so historically, there was much higher, there were phosphorus loads and flows intruding to the marsh from S6, which is a pretty high load, and that was diverted to STA2 in 2001, I guess it was. And I think that helped a lot to reduce the concentrations in the interior because, as I said earlier, the interior marsh concentrations have trended down when you look at the long period of record. And no, it could very well be. I think you mentioned recycling of historical loads from the sediments. So some of these sites we may very well be seeing the antecedent effect of those loads. It's just that it takes a while for the cycling and for the effect of those to decrease. That's it.
Okay.
Thanks, Bill. So my last comment.
Oh, you
is-
said you already said you had a last comment. No more.
No, I said that was my last question. My last comment. My last comment is what I don't see in the presentation is the influence from the inflows. So we do know that these inflows are still elevated above levels that are protective of the marsh right now, and not understanding how that is not being characterized here. And so I do think that a discussion of that is warranted. And I know there have been correlation analysis thrown at trying to relate that to that, but like I was pointing out earlier, it's not as simple and straightforward as a correlation analysis. And so I think that needs to be considered, because it's not as soon as you pump the water into the canal, it pours into the marsh interior and we get in a signal of intrusion. It's being loaded in the marsh, and then over time we're getting these pulses that release it and some other dynamics that are driving some of these higher points. So I think that is something that needs to be considered as we continue to investigate these type of events. Thanks.
Thank you. Let's hear from the others, including Mark. I know you're hanging in there with us from afar. Do I have other comments and questions from the reps?
Yeah, I just wanted to, I wanted to echo what others have said and thank you both for a great presentation, very thoughtful, and obviously a lot of work put into it. And I really appreciate the opportunity to look at it in advance, because I'm probably a little slower than others and I really needed some time to really think about it. So I appreciate that very much. Donato and others have brought up some factors, questions that I had written down also, and I have other comments or discussion points, and I don't know if that's all necessarily has to be done in this forum, or if it's possible that we could meet as a group and maybe kind of talk through some of these things in another session. Is that something that's possible?
Actually, I'm glad you asked that, because one thing I was going to say is I'm trying really hard to take notes, and for me to figure out later what all everybody thought should be looked at is going to be tough. So it would be really great, and maybe Jody could facilitate an offline discussion with you guys so we can kind of collaborate a little further.
I would really appreciate that if you guys are open and willing.
Yes, absolutely. Happy to do it.
Okay, and Jody, maybe ask the reps who they would like to have participate, just so we can be complete, because maybe Ed has someone on his staff who would be interested in participating, but I see a lot of collaboration happening here, because it was really when things got together, so it would be great if that could happen. So.
Okay, thank you. Jody, you and I can work together to form the group and schedule something, if that works.
Yeah, that works for me.
Good deal, thank you.
Okay, for those of you in the back that are keeping track of action items, that can be like your #1 action item to make sure happens. Anything else here at the moment? Mark, I didn't know if you had comments. I just wanted to kind of...
I just wanted to thank the team for putting together a nice presentation and being very thorough, having a thorough presentation and explanation of some of the work and answering the questions. I also am encouraged by the proposals for supplemental monitoring at the Loxate station. So that's basically all the comments I have at this point.
That's great, thank you. And Ed, you look like you're about to make a comment.
I was just going to echo Mark's comments, particularly about the additional investigations. I think that's going to be important for us to have, that information to actually kind of get a better understanding of things. The one question I did have is how long do we think that investigation would need to occur before we could actually get to some kind of resolution? Obviously, it's not like a 1-month thing, because there's going to be a lot of variations throughout, time, but just a thought.
And I actually couldn't even answer that at this time, so maybe the group could kind of figure out, because it sounds like, not only are we looking at the cameras already, but some of these other things may not be fully in progress right now. So, the guys and gals only get out there once a month. Even installing the signs is something that would have to be resourced and dealt with. So it's not going to be tomorrow. That much we know. So, okay. All right, anything else on this presentation at the moment? Many of you should have noticed on the agenda we had a little asterisk there in case we actually thought we had something to vote on. I'm assuming, but you guys could confirm whether we wanted to vote anything, which I assume we don't, but
I would say we would hold off on a vote until we can get together and come up with a path forward with the team.
I would say that that's based off of what we've seen today, that's a wise approach. So if we can hold off at the moment.
okay, thank you. And I, of course, agree, but I need y'all to weigh in, so. All right, so that being said, you guys are going to get together, you're going to form a little team and move forward, and that is going to probably include this extra investigation. I think it would be great if you guys could discuss that. Before we close the meeting, we do have a working group update from Jody. So Jody, I don't think you have slides for this, but if you could give us a quick update on the S333 working group, we'd appreciate that.
Yes, happy to. Okay, so the last time I gave an update on the working group was our last meeting in June. I provided a schedule. That schedule remains as was presented. What has occurred since our last meeting? Good news, we got governing board approval at the August meeting to enter into a construction agreement with the selected contractor. Again, I mentioned at the last meeting that the construction agreement includes both tasks 1 and tasks 2. So that's going to further, facilitate undergoing both, all aspects of the project. So currently, contract execution is underway. They're wrapping up contract negotiations, and the notice to proceed for construction is planned October 1st. So that puts us, the last time I presented about a 4-month delay in the schedule, and that was due to not having received all of our permits at the time. But we wanted to try to make up the schedule as much as we can, so we went ahead and we solicited the project before receiving that last permit. So that kind of bought us a couple of months. So if you look at the schedule that was presented last time, we were showing construction to start, I believe, in December. So now we're looking like October. I didn't make that adjustment to the schedule just because we're, at the onset of the wet season. But I just wanted to share that good news story with you all, that things are moving along as far as getting moving with construction. So the next item I wanted to highlight are the permits. So we have received all permits for task 1. So that's another good news story. Task 2 permits, all of the permit applications have been submitted to the respective agencies and are under review. This includes the Section 408, the Section 404, as well as the permit that we need from DEP. So all final permits are expected no later than November of 2025. So that's still what we are planning for. And that is all I had today as far as the working group update.
Okay, thank you, Jody. Comments or any working group questions? Okay. Public comment in any way for the meeting today. If you have dialed in as an attendee, you can certainly raise your hand in Zoom, or you can, if you're on the phone, press *9 to raise your hand, or *6 to mute and unmute. So do we have any public comments today? Okay, I am not seeing any raised hands, but everybody's been really hanging in there today, so that's great. One last item for the reps today is our next meeting. The current schedule for the next meeting is December 9th. The rumor mill has it there may be some conflicts with that date, but I wanted to check with you guys, or we're still planning to meet on December 9th.
Yeah, this is Ed with DEP. The task force meeting has been tentatively rescheduled for December 9th, so I think, it would be beneficial for me if we could adjust our TOC meeting, because I'll be expected to be at the task force meeting in DC at that time.
Donato is giving me his direct feedback over here on the side. So a couple of things for you guys. First of all, we do still have December 4th, which I think is a Thursday, was a possible tentative date. And then Violetta was kind enough to find us a couple of dates in January that may be available. They are both Tuesdays. One is January 13th and the other is January 27th. So if I could get your feedback on those three things, we could firm up our next meeting.
January 13th and the 27th both work for me.
Both dates work for me.
January 13th and 17th work for me as well.
I can't speak to Dan's schedule, so I'll have him get back with you.
Okay, thank you, Mark. And what about you, Mr. Barquette? Would either of those dates in January work for you?
I'm looking.
You're doing
said
that. Go ahead.
You said the 13th and the 27th, but then I heard somebody say the 17th.
That was a typo. So 13th and 27th are the dates we're looking at.
Let's see here, January. That's a new year, isn't it, January?
Allegedly, yes, sir.
Yeah. Right now, the 13th is okay. That's what day of the week is that?
That's a Tuesday. Both of those
It's
are
Tuesday,
Tuesdays.
right? And the 27th, what does that say? 13th would be better.
Okay, and that
than the
has given me,
27th. And then you said December 4th also? Is that still viable?
sounds like December 4th may not work at this time.
Okay, and the 13th would be best for me.
Okay, is everybody okay with January 13th? I think so. All right, so our next meeting, instead of being December 9th, will be January 13th, and hopefully folks will have a chance to get together between now and then. All right, thank you everyone for attending, and we will see you, oh my gosh, we'll see you here next year. Thank you.